Okay, so hello everyone, it's Mr. Rops here, and I'm going to give you a quick introduction to these things called the quadratic family, which we've worked a lot with. And you should recognize that f of x equals x squared means it's quadratic. Whenever we have some kind of an x squared, it is the quadratic, and this is what we call a parent function. We take this and then we change it, we move it around, we stretch it, and so on. And so here's our basic graph. It goes through here. This point down here is called the vertex of the parabola or the quadratic. So if it was here, this would be the vertex, the lowest point, or if it's upside down, this is the vertex, and so on. Okay, I know when I make my table here, I get x, I get f of x, my y value. And if I go -3, -2, -1, 0, 1, 2, 3, well, starting at 0, I can see that 0 is, if I square 0, I get 0. I go over 1, up 1. Over 1, up 1 gives me 1, 1, because 1 squared is 1. If I go over 2, square 2, I get 4. Over 2, up 4, and I get this point here, 4. So I take this x value and I square it when I put it in. Over 3, up 9, so on. And I go -1, I go over -1, up 1. Because -1 squared is +1. -2 squared over 2, up 4. And that pattern is true for any quadratic that has an x squared in it. When we have what we call the a value is -1. And this a value in standard form is the same as this a value in factored form, and is also the same a value for what we have called vertex form. So this a is the same for all different forms. In standard form, you're familiar with ax squared plus bx plus c. Even factored form, you guys have seen factored form a fair bit, because these are the factors. And vertex form you're less familiar with, but we have seen this form somewhat, especially when we're going to do PEMDAS backwards to solve things. We see vertex form because HK is our vertex. There's more to come for that. I'm just introducing some of the notation. So the vertex happens at our minimum, or it could be our maximum as well, wherever the vertex is. For our parent function, it's 0, 0. We also have this thing called an axis of symmetry. And so if I think about symmetry, I know if I draw a line right straight through here, my graph is this half of the graph is symmetric over this line, and I get this half of the graph. And so the axis of symmetry in this case is x equal to 0. This x value of the vertex and the axis of symmetry are always the same. For our parent function x squared, well, our x-intercepts and y-intercepts are the origin, 0, 0. Note the y is 0 for the x-intercept, x is 0 for the y-intercept. And just so you know, for x-intercepts, they're also called roots or zeros. So that's another way to ask for x-intercepts, or it could also be called solutions as well. And then the last thing we'll talk about is the domain and the range. What the domain is if I, here, let me just clean up this graph a little bit here first. Okay. If I take a line, let me put a line on here. If I take a line, a horizontal, a vertical line, and if I move it from left to right or right to left, if it touches the graph, then it is part of the domain. So it touches yes, 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 touches yes, 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 yes. Even here, eventually it will touch. And I go this way, eventually it will touch. Everywhere this line will touch the graph eventually. So that means that x is part of any real number, what it could be. And then finally when I do the range, what I do for the range is I take a horizontal line now, and I move it this way. Oh, and I take my horizontal line and move it. And so wherever it touches the graph is where the range exists. So no, 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 yes, 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 yes. It touches the graph, yes, 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 no, 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 no. And so it touches the graph and I say yes whenever it is y is bigger than or equal to 0. And that here is what we have as the range. So there's just some basic definitions and ideas for our quadratics. We'll use the building blocks to do various things and find the equations or find the graphs, graph it, and we'll move from there. There's your introduction to quadratic functions.